Okay, so remember, this part of the notes is about volume. So we learned part of this, very like going over the formulas, last class meeting. This is topic, it doesn't say it on this page, mine printed on the other page, but this is your topic 12.4 volume notes. So it goes with the 12.4 homework. So when we're talking about volume, it's like we're filling up the object or whatever it is. So basically you're really just finding the area of like the base of the object, and then you fill it up by multiplying times the height. But you have formulas that you're using. So that's why in this one, we multiply length times width times height. And that's like it's filling up that like cube or that rectangular solid. A cylinder, it's like you find the area of the circle that's in the bottom here, down here, and then it's like you fill it up. So you use the area of a circle, which is like taking radius squared times pi, but then we multiply times the height, and that gives you the volume of that. So you don't have to memorize these formulas. They'll be given to you, but just know how to use them. Most of the time, they do tell you for pi to use 3.14. I think we talked about this last class meeting. Every now and then they might say use 22/7. And really it's just a fraction that you would just replace for it. But I would like to say it seems like you never use the pi symbol on your calculator, because then you would be given rounding instructions to have to round. Otherwise, I don't think there's any rounding instructions. So if you do get a problem that has like 4 decimals, you do have to put all 4 down or it'll count it wrong. Okay. So just pay attention. If you see rounding instructions, do that. But if not, then you use all the numbers you see on your calculator. A sphere is taking 4/3 times pi times radius cubed. And so just remember when we're talking about like cylinders and circles, like with circles, we talked about this in area as well, but all the way across is your diameter. So sometimes you may be given the diameter and have to go find the radius. So in all these volumes, you're always working with radius, not diameter. So like if the diameter is 10, then that means the radius is half that, right? So you would divide by 2. So just remember that small little thing. I think we know it. Sometimes we forget to do it, especially if it's a decimal number. So like say your radius is 0.4, make sure your diameter, is 0.4. There's a problem like that in the area one. Make sure you divide by 2 and then use that 0.2 squared and stuff like that. Okay. Or whatever. I can't really remember what the problem is exactly, but something similar to that. So we went over just a couple of those. Now we have some application to do on this. So it says, find the volume. Oops. Oh, my stuff is different. It's okay. I can do it. I just like to have my stuff in front of me. Okay, so it says, find the volume of a rectangular solid with a length of 4 feet, width of 2.5 feet, and the height of 2 feet. So really, you just need to go back to your rectangular solid formula, and you can draw pictures. So we know that we're using length times width times height formula. If you like to draw pictures, it has like a length of 4 feet. It has like a width of 2.5 feet. And then it has a height. So you have to be a good artist. See, I'm already like not doing a great job, but maybe a height like this, if you do draw it, of 2 feet. So if you like to see pictures, that helps a lot. But you're taking 4 times 2.5 times 2. So really you could just say my length is a 4, my width is a 2.5, and my height was a 2, and just replace those into that formula if you're not an artist like I'm not. I was telling my supplement class, Amy, on Monday, that sometimes I get really nervous when I draw pictures in this unit, because I'm not an artist, and a lot of times our art majors are in this class. So I'm always like, they're judging my shapes.
It's abstracted. That just makes it classier.
Yeah, it's great. Okay, so this would be 20. And remember, when we're talking about volume, it's cubes. So we'd say feet to the third power, or feet cubed. Cubic feet is another way, like some people like say it verbally. But WebAssign labels it for you, so you don't have to. But it is important to me that you know that with perimeter, it's one-dimensional. So like that would just be feet. If it was area, that's two-dimensional. That's talking about length and width. That's what we mean by dimensional. And then volume is three-dimensional. So it's important to me that you know it, but WebAssign does label it for you, thankfully. Okay, so the volume of a cylinder with a radius of 10 centimeters. So, you know, you have your cylinder like this. It's really not a good cylinder, but if my radius, you can go on the bottom or the top, however you want to write it, from the middle to the outside of that circle is 10 centimeters and the height is 45. So really you just need to know what formula to use for the most part. And that comes from that page before. So your volume is pi times radius squared times height. And they will tell you probably to use 3.14 for pi. Sometimes they tell you 22/7, but we're going to use 3.14. So we're just replacing everything with a value up here. So we have 3.14 times radius, which is 10 squared times my height of 45. So let's go do that. 3.14 times 10 squared times 45 is this really big number. And that's in centimeters. So we do centimeters cubed. So just be familiar with the formulas, kind of like you did in that business unit, and know how to plug stuff in. So a sphere, really can't draw a sphere. I mean, it is so embarrassing almost to me how bad I am at this. So this is my sphere. Very abstract. But it says find the volume of a sphere when the diameter, so let's just talk about the circle so I can do that, is 14. So that's what I was telling you. So if my formula, so my diameter is 14 inches, and if my formula for sphere is 4/3 times pi times radius cubed, I have to decide what my radius is if my diameter is 14. So we just divide it by 2. So that means my radius is 7 inches. They give you enough information to go figure that out. So we're going to say 4/3 times 3.14. I would venture to say a lot of times with sphere, they may tell you to use 22/7 because a lot of times it will actually get a little bit more accurate. Maybe not, just depends, I guess. And then 7 raised to the third power. So fraction is 4/3 times 3.14 times 7 to the third power. And so this one, like, is an example of it has a long decimal. And now that one wouldn't be ending. So it would probably tell you to round. Or maybe on one like this, I'm going to go just see what happens if I use not 3.14. I should have looked at the assignment to see when they use 22/7 for the most part. I don't want that or that. I'd like to just do times. Okay. And then I'll go ahead and say times 7 to the third power. So either way, you get like something that's repeating. So let's go ahead and use our 3.14, and then you would probably be told where to round on this one in WebAssign. most of the time they're using 3.14. Very rarely I've noticed that they will tell you to use the 22/7. So this is 1436.0, and maybe they say round to the hundredth, so it'd be like 03, right? We'd round that 2 up to a 3. Just make sure you're paying attention to rounding instructions so you can get it right. Inches cubed. Okay, so this one is like partially printed on the first page and the second page. So I'm sorry about that. I'll read it and then I'll kind of write some stuff on the next page. So it says, use the diagram below showing the concrete floor of a building at a cost of $10 per cubic foot and find the cost of having the floor poured. So there's actually a picture over here with some measurements. So it didn't look like a complete problem probably when you were first reading it. So I'll put it up kind of like that so you can see it. So the first thing that we would do is we need to split this into different shapes. Okay. So when you're pouring concrete, it's going to be a thick slab, right? And so that's what they mean by like the cubic feet. So they're trying to simulate that to show you the depth of it. So it's not just like the area, but there is some depth because maybe you want a 2-inch patio, or maybe you want a lot of patio. Like I saw someone recently in Tonkawa had a new patio poured. It's really pretty. It's like 6 inches thick. It was really big and it looked really great though. But like maybe 2 inches compared to 6, that's a lot more concrete, isn't it? When you're talking about a whole area of space. So, so that's what this is. Like this would be like 6 inches deep, it looks like. And so length, width, whatever you want to call it, we do need to find the total like volume of each shape. So let's talk about the rectangular one. So rectangular prism. Sometimes I have to say it slow, so I'll spell it right. So it looks like I have all the measurements right there that I need to do this. I'm trying to figure out what she did. Oh, I know what she did. So we need to make sure we're working in all the same units. So do you notice that these two are in feet, but this is in inches? What could we turn? How could we turn 6 inches into feet?
0.5.
Just 0.5. That would be the best way. So let's call this 0.5 feet. So that's a little introduction what we'll be doing in chapter 8. So it's like you divided by 12. And so if you, I know probably everybody knows there's 12 inches in a foot. So it's like you divide by 12 and you just convert it to say that's like saying half a foot, which would be like saying 0.5 feet. Okay, so now we're going to find the volume of this right here. I'm not going to color it today, but we would just take for volume, length times width times height. I will write that down. So maybe my length is 40. My width is maybe 80. Doesn't really matter which one you're calling length or width. And then my height is maybe 0.5. Maybe you called the length 80 and the width 40. Doesn't matter. So we're taking 40 times 80 times 0.5 means the volume of that rectangular section is 1,600 feet cubed. So maybe I will like at least outline it. So that's in here. That's the volume of this, right? So now we need to go find the volume of like a cylinder, but is that a full cylinder? Think about circles. Okay, it's not a very deep cylinder, is it? It's kind of a ½ inch or a ½ foot, but it's half a cylinder. So let's do let's do half cylinder. Let's write that down. So basically you're going to take your cylinder formula and then just divide it by 2. So your cylinder formula is V equals pi times radius squared times height. And then because it's half, we're going to divide that by 2. So we need to think though, what would the diameter be of the cylinder? If this length from here to here is 80, isn't this 80? Right? So the diameter is kind of like, I'm going to write that there. Your diameter is 80, but I need to know radius. So what would the radius be if the diameter is 80 of that cylinder? It would be half that, right? So you divide by 2 and it's 40. So we're going to use 3.14 for pi. And then we're going to say 40 squared. And our height was half a foot. Okay, so remember this height is still just half a foot right there if you want to do that. And then we're going to divide all that by 2 because this is half a cylinder. So let's type that into our calculators. 3.14 times 40 squared times 0.5 over 2, because we're going to divide it by 2. So that would be 1256 feet cubed. So that would be like if we were figuring the volume of this section right here, that would be the volume of, oh, you can't see what I wrote. I am so sorry. There you go. That would be the volume of that. So the total volume, or, for this concrete, we have to find that first. Total volume would be adding those together. So 1600 plus 1256 would be what? 2856, yeah, feet cubed. But they asked us really what's the cost. So it tells us it's $10 per cubic foot. So all we have to do is take that. So, all right, find the cost. So we have to take that 2856 cubic feet times $10. Wrote my 0 before my 1. So that would be $28,560. I wanted to keep my thing in the screen today. My apologies. Okay, so that finishes up the volume notes. That will be your 12.3. We're going to go do Pythagorean theorem. Probably sometimes when you're a traditional student, you really remember Pythagorean theorem like it was drilled in your head. And then if you have been out of school a little while, you may not remember it at all. If you're a welder, you probably have used it in your life every day. I have a friend that's a machinist, and he said he uses the Pythagorean theorem every single day in his job. So it just depends on like your real life work, if you ever use this or not. But so 12.5 is your Pythagorean theorem. My notes are kind of off, so I'm going to write it again on the top of the next page. So this is the start of 12.5 notes for your Pythagorean theorem. So something to kind of understand before we get going with it is like square roots and perfect square numbers, because we use that a lot in this unit. So a square root or a perfect square number is like saying, if I take 1 times itself, I get the number 1, right? Right? If you're taking a number times itself. Another way to write that is like 1 squared, because there's 2 of those there. I usually write that just opposite of what I just did, but it'll work. And so when we take 1 times 1, we just get 1. Well, what we're going to be learning is like, this is a perfect square number. If we take the square root of that number, wish this was said backwards, like let's write it back up. Perfect squares and square roots. I like it a little, I like to just flip-flop those words on your notes, because we're going to talk about perfect squares. And then what we're learning is if we take the square root of this number right here, we go back to like whatever number it was that we squared. So we're going to do that with just maybe up to 12 numbers, just so that you can see it. So if I say, if I take 2 times 2, that's like taking 2 or writing it as 2 squared. You can write it either way, a number times itself. And that's the number 4. When we take that 4 and square root it, we get back to the number 2. If I take 3 times 3, which we would also see it as like 3 squared, that gives us the number 9. If I take the square root of 9, it takes me back to 3. So perfect squares and square roots are inverses of each other. Something that like I teach in algebra is if I were to see 3 squared and I take the square root of it, it's like it cancels out that square in a sense, right? It's like you're undoing the square that you just did. And that's kind of important with the Pythagorean theorem. I don't think I'm going to make that list super long, like I just said, just because of space. But 4 times 4 is actually, I should write 4 squared, huh? I skipped it. 4 squared is 16. But if I take the square root of 16, I get back to 4. So 5 squared is 25. If I take the square root of 25, I get 5. And we can do that forever and ever and ever, on, infinity. But I'm really just going to stop there because we use our calculator a lot. So you don't really have to know the perfect square numbers or anything like that. Sometimes we take a square root of a number that is not a perfect square. So I want you guys to look at this. Like, I cannot take a number times itself and get 7, can I? Like, that's not a perfect square number. I can't take the square root of 7 and figure that out. And so what you're going to see is in your calculator, it's either going to be like that, have a radical, see how it didn't simplify. If I took the square root of 16, it does. But like a number that's not a perfect square number, your calculator, when you have it like mine, will do this. So you, I do need to teach you how to do the square root, don't I? So hit your second key. And then it's just above your x squared key because they're inverses of each other. All those things in greens are always inverse operations that's happening in your calculator. So you'll hit that. So you had to hit the second to get to the green, which is above that x squared key right there to the left of your number 7. And then if you type in 7, click enter. You're going to need to turn that into a decimal, like tell your calculator to do that, just like you did with fractions or whatever in the past. And it's just that double arrow key. And then you'll be given instructions on where to round in the Pythagorean theorem stuff. Okay. So let's go look at Pythagorean theorem. So first, let's talk about right triangles. So this only applies to right triangles, meaning you would have a 90-degree angle in the triangle, however it might lay for you. Like this would be the 90-degree angle. This one, they kind of try to throw you off, is supposed to be a 90-degree angle right here. It looks a little weird when it's turned, but it's supposed to be a 90-degree angle. And so whenever we talk about the legs, that's kind of important because that goes with your Pythagorean theorem. Those are your A's and your B's. So like this would be a leg and this would be a leg. And really it doesn't matter which one you call A and which one you call it B. So like A and B, it's just that they both get an A, or, you know, each leg is an A or the B. And then whenever you draw a line to connect them, they call this your hypotenuse. And that's always the letter C in your formula. So we're working with A, B's, and C's. And so over here, if the 90 degree is here, your legs are the two lines that connect and make your 90 degree angle. Okay, so this is a leg and it can be leg A, and this is leg B. You guys remember perpendicular lines, that word? Okay, so like perpendicular lines always make a 90 degree angle. And so then this would be considered your hypotenuse. So sometimes I just put height there, and that's our C. So that's really, it's important to understand what is a leg compared to your hypotenuse is the long one. It's a longer one that draws between your two lines that made a 90 degree angle. So our Pythagorean theorem is the sum of the squares of the length of the legs. So if A was 2 and B is 4 or something like that, you would square those numbers. And they're saying that it is the sum of the squares. I like to say A squared plus B squared equals C squared. I like to put my C squared on the right-hand side. So I'm just going to squiggle that out and put it over there. So I know that at least for me, my application is over here. We'll just have to turn the page and fix it. So remember, this is like a leg squared plus a leg squared is going to equal whatever your hypotenuse squared is. That's all your A, B's, and C's represent. So it says find the length of the hypotenuse. Let's turn the page and we'll redraw this draw this triangle right here on the next page. So it says find the length of the hypotenuse, which is your C. And we'll write that in a minute. So this would be an A, and this is a B, and this is a C, right? Because that's what your figure should look like if it were all printed on the same page. Go ahead and jot that down, will you? So this is like your A value, and this is like your B value. Doesn't matter if you switched them either. So if I'm saying A squared plus B squared equals C squared, this is your A value. So we take 5 and we square it because that's in the formula. Plus 4 and we square it because that's in the formula. And that's going to equal some number squared. So what I do is I just type this into my calculator just like this. So I'm going to say 5 squared plus 4 squared, and that will give me 41. So if I need to know what C is and not C squared, so that's what this means. I actually don't know this C value. I don't know this length. What I know is whatever C squared is. Remember, how do we undo something that's squared? What's the opposite of squaring it? We square root it. That's why I kind of showed you that. It's like we're getting rid of that. So if we do that to our C, we have to do it to this number right here. So we're going to be taking the square root of 41. So take the square root of 41 in your calculator, and it's going to look like a radical. So you have to take the square root of both sides. And then in your calculator, you're going to have to hit your double arrow. And I kind of think that in this one that they round to just the nearest tenth. So let's just go ahead and write, this would be like saying 6.4031. I just wrote some, but if it tells you to round to the nearest tenth, wouldn't it just be 6.4? Okay, number 2 says find the length of the hypotenuse again. So that would be like C. Again, we also know it's C because this looks like a right angle right there, doesn't it? That's the, obviously this isn't a right angle and this isn't. So if your eyes are playing tricks on you, They will be right angles that you're working with. So this would be like your A value and your B value. So if I'm taking A squared plus B squared equals C squared, then we're going to write 24 squared plus 10 squared equals C squared. Some people simplify your squareds first, then add, but I would just type all this in your calculator exactly the way that you see, so you don't do something wrong. You would have to square it first if you're doing a separate step. But 24 squared plus 10 squared equals 676. So all you do from here is, since I need to know what C is, not C squared, we take the square root of that. That's what kind of gets rid of the squared. And if you do that on the right, you have to do that on the left. So in your calculator, you take the square root of 676, and that happened to be a perfect number. Doesn't always work out that way, but sometimes it is. So 26 equals C. I personally don't have 26 to the second power memorized. That's a big perfect square number. Do any of you remember some of this a little bit? Some people say no, and some people say yes. Okay. So on number 3, though, sometimes we're going to be finding the length of like a missing leg. Maybe not the hypotenuse. And so think about what's happening. A squared plus B squared equals C squared, right? So what we don't know maybe is like this. So you're going to have to do a little algebra, and then I'll show you maybe a shortcut that helps a little bit, because this would require you to do a little bit more work in your calculator. So let's say that maybe this is my A value and this is my C value, but maybe I don't know B. And if you traded and you called that B and this A, it doesn't really matter. It still all works out. You're just finding the unknown leg. So I'm taking 330 and I have to square it, plus B squared equals my C squared, which is 650, and I square it. If you don't like squaring it, because these are going to be big numbers, we could take this whole thing, at least this is the way I like to do it. How would I move that over to that side? Does anybody know? Subtract it. So we really could say, well, if I only want to have to type it in my calculator and not pull it apart and write down big numbers, you don't have to. You could say you're taking 650 squared minus whatever 330 squared is. As long as you don't actually subtract something, like yet until after you square it, I guess that's fine. So we could just type it as a minus in there. So 650 squared minus 330 squared gives me my B squared is this big number of 313,600. So if I want to know B, not B squared, don't I go take the square root of that? Which is 560. So that one's a perfect square too. So really, like, I like to just type it in. I don't like to have to squaring it, write it down again, but you can just make sure if you are doing that extra step, like in this one specifically, you'd have to do 24 squared was, let's say, 576. 10 squared is 100. You can write those steps out. That's technically what's happening to get to there. But since we have a calculator, I like to just say you can type it all in just like that. You don't have to do order of operations if you don't want to. We learned order of operations a long time ago in this unit or in this class. But if you're doing it just like this, it works out pretty good too. Okay, so the next one says, how long is the ladder? And the picture's on the next page. So let's turn the page. And they kind of make a, not kind of, they do. I have a picture for you. Right here. This is number 4. And you can barely see it because it's within that picture, but they're telling you that the top of that ladder from here to here is 40 feet. So let's pull that triangle out here. It kind of helps to see it. And then from the bottom of the house to the end of the ladder is 60 feet. And so what they're wanting to know is how long is this ladder, which would be what part of that right triangle?
C.
The C part, yeah. So we know A is 40 and B is 60. We need to go find C. So remember, we're taking A squared plus B squared equals C squared. So 40 squared plus 60 squared equals C squared. So let's get our calculator out. And I just type it in just like that. I really am a big believer in writing down steps, but this one is definitely a nice shortcut since our calculator can do order of operations for us. And then we would take the square root of that number because I don't want to know what C squared is. This is really C. So in the formula, it's telling us that the sum of our legs equals the square of that hypotenuse. Like it's everything's square, but we got to get back down to where it's not squared to get the actual measurement. So we take the square root of 5,200 and we'll probably, I'm almost positive that you round to 1 digit. So this would be like saying 72.1. I assume that that's in feet would be our answer. So a little more than 72 feet. Oh yeah, it is feet. It says it right there. Okay, so we have another triangle. This time we know the ladder and it's going up to a window. We know the ladder is 10 meters long. They're saying from the bottom of the ladder to the base of the building is 5 meters. So they want to know how high, there's not like words with it, but basically that's what they're figuring out. How high is it from the top or the bottom of that window to the bottom of that building? So we're going to be saying A squared plus B squared equals C squared. Because this is 3-dimensional, they're assuming, you know, that this right here is the bottom of the building. So it looks like it's pulled down, but it's really not. Okay. So I do know my C value and I know maybe my A value again, but maybe I don't know my B value. Okay. So really, before you even do this, this is what I was going to show you. You could rearrange this formula. If this is my unknown, where H is kind of like, let's call that B. If this is our unknown, we can just subtract our A over and say B squared then equals whatever C squared minus A squared is, right? Which is really all we did when it was just numbers, which I'll write that down for you. So if I say 5 squared plus what I don't know is B squared this time, this is the unknown, they called it H because that's the height, equals 10 squared. If I needed to move that over to do the math, I would subtract it. So I would have B squared equals my 10 squared minus my 5 squared. So we can just make our calculator do that. That's like I saying 100 minus 25. If you know your squares pretty good, you probably know at least those. Like those are ones that a lot of times we've memorized, at least around to about 10. So we have B squared equals 75. So then we would take the square root of that to find our B value, which is representing the height of that ladder, how high it was able to go up there. So we're going to take the square root of 75 and it will make it look like that. Looks kind of weird and something we haven't seen yet. Go ahead and hit your double arrow to turn that into a decimal. So it's like saying 8.660 was my B value. But we're gonna round to one digit, so we're gonna say B equals 8.7. Okay, number 6 says, suppose that you drive 4 miles south and then 10 miles east. So this is kind of supposed to represent south, and then you go east. How far away are you from your starting point? So if you could like measure, like say this was a county miles or whatever, and if you could just draw the shortest distance back, that's what this is asking. So you're really just finding your hypotenuse value, right? Because this created a 90-degree angle. So they're saying if you drive south and then you turn east, that makes a 90-degree angle. So we have C squared, A squared plus B squared equals C squared. So we're saying like, maybe this is A, maybe this is B. So 4 squared plus 10 squared equals C squared. You guys doing okay on this? I feel like we're just kind of rolling through and seems like you're doing it okay, but if you have questions, stop me. So this would be 116 is representing the C squared number. But remember, we need to know C because that would be the actual distance. That's representing C squared. So we take the square root of that. And it'll turn it into like a funky looking reduced radical, but hit your double arrow. I'll just write it this time to turn into a decimal. So did I do that? Did I hit my double arrow? I don't think I have yet. There we go. So if we rounded to one digit, that'd be like saying 10.8 is our C value. So almost 11 miles, if we're talking miles, which they were. If you're running that, you're probably going to round up, right? I ran 11 miles today. All right, last page of these notes, and then we'll be done. I actually have never seen an example like this, so this will be my first time doing it. I thought I looked at these notes, but I didn't. It says a baseball field is larger than a softball field. The bases are 90 feet apart. Diego is at second base and throws to Omar, who is exactly between third and home. So they kind of have a dot here. Do you see that? This is what they're representing, second base in between third and home. How far must Diego throw the ball to get it to Omar? And then it says, write and solve an equation to explain your answer round to the nearest hundredth of a foot. So if you want to, we can pull that triangle out that you see. Maybe you want to turn it like it shows there. I didn't, but like they're saying from here to home, I didn't make it the same looking distance is 90 feet, but so would from third to second base, it'd be 90 feet. So it's making a triangle, a 90-degree triangle in there. It's a really dark picture, especially on the overhead. But if you printed your notes, you'll see that they have little dots there to help you see that triangle. So we're trying to find our C value. Actually, let's go backwards. This, if he's right here, is he all the way to the 90 feet? Because wouldn't that be there? Okay, I messed up. Sorry, guys. This is my first time doing it, so I'm looking at it as we're doing it. So he actually throws halfway, like he's halfway through there. So there's 45 feet on both sides of Omar. This is Omar. I should have made a little stick person. That helps me. That's Omar. So he's actually 45 feet into that triangle, isn't he? That makes more sense because you'd have to go all the way down to do 90 and 90. Now we can go solve and see what his distance is between here and here. So we'll say like maybe this is A and maybe this is B and this is our C value. So 90 squared plus 45 squared equals our C squared value. So let's go type that in. 90 squared plus 45 squared is a big number, 1,125. And then we just take the square root of that number to say, so we go here, we'll say that round to the nearest hundredth, so 100.6 is our C value. I was gonna write feet. I'll go ahead and do that. Is our feet value. Is our C value, so it's feet. Oh, it said round to the nearest hundredth, not tenth. So hundredth would be like saying what, 100.62 feet. Make sure you're not like me and you didn't do by habit. I did tenth, even though I even said hundredth. So 6.62. And so now we've got one more problem. And so softball, how far will the softball travel if the girls throw the ball around? So it's doing a lot of them. What are we doing here? Okay, so we're gonna have to figure like 1, 2, 3, 4, 5 different things and then add it together. So it's basically, if you ever go to a softball game, sometimes they throw the ball around certain pattern. And they're saying maybe somebody throws it from home to second. And then second to third. And then third to first, and then first to shortstop, and then shortstop to pitcher. So if we're at home right here, and we throw it to second base, basically, what measurements are we using to do that one? I'm going to write this, home to second. So don't we have all the things that we need to make it? So we're taking 60 squared plus 60 squared would equal that hypotenuse squared. This would be your C value. I'm not going to write that in here because I feel like we're going to be drawing a lot of lines in a minute, okay? But this is your 90, so this is your C value that we're trying to find. So let's go see what that is. So 60 squared plus 60 squared equals 7,200. Take the square root of that. And we're going to round to the 100th again, just to do like the baseball one, I guess. So we'll say 84.85 is the C value for that one. So let's go write that over here. 84.85. I have a little hole punch there, so I did just make it squeezed in there. So we get to do 5 of them, don't we? So now we're going to go second to third. So if we're throwing from second to third, what's that distance?
60 feet.
It's just 60 feet, right? Because they're just throwing a straight line, and this was already, we're not doing a hypotenuse. That would just be an extra leg. So that's 60 feet. So actually, we didn't really have to do anything there. And then we're throwing third to first. How would we find that? It's going to be the same. Yeah, third to first would be the same distance. So it's like you did 60 squared plus 60 squared, which we already know is 84.85 is the C value when we do that, right? So let's go write that, 84.85. Now we're going to go from first to shortstop, which is usually right about here. Not exactly, but we're just gonna pretend it's right in the middle. They're assuming that. So what would, if we said shortstop was right in the middle of second and third, what measurement are we gonna use for here? Yes, kind of like we did up there. We're gonna say half of that would be 30. So for our first, the shortstop, we're taking 30 squared plus 60 squared is going to be our C squared. So we did have to do this measurement and this measurement, and this one was the same as that. So really, we've only had to do 2. 30 squared plus 60 squared is 4,500. And so that would be like 67.08. So 67.08. And then just kind of thinking about this, if your picture's right here and she throws, it's a shortstop to pitcher, what do you think that distance is going to be? They're saying she's right in the middle of that square. Think radius, right? So just 30 again. So they're saying that the pitcher from short to pitcher would just be right in, like say right in the middle. We make a lot of assumptions. That's just 30 feet. Kind of like maybe like radius, I guess, but applied to squares. So we're gonna add all those together, and this will tell us how far that softball traveled when they did their little roundabout celebration throw that they do. What do you call that, baseballers?
Round the horn.
What is it called?
Round the horn.
Round the horn? Okay, my husband was very disappointed in me that I didn't know that. He played baseball for Northern when he was here many years ago. Many years ago. I think the program was just starting up actually back then. Okay, so 326.78 feet. He was a pitcher, but he had thrown out his rotator cuff right before season started. Yeah, so he kind of, I think, hated it. I mean, hated that he didn't get to one of the years anyways, pitch much. Total distance, that's what I was going for. Okay, so we got through our chapter 12 stuff. So remember, we are learning chapter 8 stuff. Just a friendly reminder, those chapter 8 notes are actually way back in chapter 1. I know it's weird. So you may need to go back and just print those notes if you had discarded them. I think I might have discarded mine or I put them somewhere. So I had to go in and just tell my printer to print those chapter 8 sections of that long printout personally. But hopefully you did keep them. You followed directions better than I did for myself and that you have them. So a week from today, we'll start learning chapter 8 because remember Thursday, we don't have a class meeting because I will be in a math conference that day. But you do have the 12.3 and 12.4 due that day, even though we don't have class. Okay, so tonight your 12, I think I said it backwards just now. Your 12.3 is due tonight, which is your area. Your 12.4 and 12.5 is your volume and Pythagorean theorem, and that's due Thursday. All right, have a good day, guys.